Poštovani kolegice i kolege, članovi simpatizeri Udruženja za digitalnu transformaciju u Bosni i Hercegovini, evo kako smo i obećali, u 2021. godini, nastavljamo sa serijom besplatnih webinara koje smo vam u mogućnosti obezbijediti uz pomoć naših sponzora. Ja bih se svima želio zahvaliti što su izdvojili vrijeme da pogledate, ja bih rekao, ovaj fantastičan webinar koji smo samo za vas pripremili s pomoć, evo, prije svega naših partnera Real Security-a i naravno pod pokroviteljstvom svjetskog proizvođača Network Detection Response rješenja ExtraHop. Ako se malo vratimo nazad prije nekoliko dana, sjećate se da smo na našem cyber meetingu, odnosno cyber meetup-u, izgradnju kapaciteta vezani za reakciju na incidente identificirali kao jedan od top prioriteta. Vodeće security kuće navode da prosječno vrijeme detekcije malicioznog koda u mreži traje čak i do 280 dana. Kao odgovor na cyber napade nameću se potrebe odgovora na 3 izazova. Broj 1 je brzina detekcije napada, znači da taj napad bude što brži i što efikasniji. Broj 2 je vrijeme potrebno za povrat servisa, znači da smo spremni odgovoriti na taj incident i da smo što više u mogućnost biti resilient, kako smo malo prije spomenuli. I treće, vrijeme potrebno da se učinkovito odgovori na cyber napade, znači da zaista vidimo u kom vremenskom periodu smo spremni da odgovorimo na takve izazove. Čisto radi, ja ću napomenuti jedan izvještaj koji sam nedavno čitao, to je izvještaj Ponemona, koji navodi da je prosječan trošak data breacha za 2020. godinu 3,86 miliona dolara. Ono što je interesantno primijeti jeste da je taj iznos nešto manji u odnosu na 2019. Međutim, ono što je isto tako interesantno jeste da su organizacije koje su implementirale automatizirane security alate, njihov trošak data breacha je bio za 2,45 miliona dolara manji u odnosu na one koje nisu. I također vrijeme identifikacije i obuzdavanja malicioznog koda je kod takvih organizacija za 74 dana bio u prosjeku kraći nego kod onih koji nisu imali automatizirane alate. NDR su alati koje organizacije omogućavaju nadgledanje mrežnog prometa. U kombinaciji sa alatima kao što su NAC, odnosno Network Access Control, ovi alati predstavljaju jako učinkovita rješenja za brzu identifikaciju i reakciju na pojavu malicioznog koda u mreži jedne organizacije. Evo, ja sam napravio nekav uvod, a sada naravno prepuštam riječ kolegi Christian Burrow iz kompanije ExtraHop da nam prezentira na koji način na ove izazove odgovara svjetski proizvođač NDR rješenja ExtraHop. Dear Christian, thank you for giving us opportunity to learn more about ExtraHop and its network and detection response tool, and how network detection response tool can be used more effectively to handle the incident management process. Christian, floor is yours.
Thank you, Sanat. Welcome, everybody. Thank you very much for joining this presentation of a brand new technology, which will be one of the future technologies for any kind of threat detections on the network. My name is Christian. I'm residing in Germany. I live in Frankfurt, and well, some words about me. I've been in the IT and data center and security industry for over 30 years, and I've been with ExtraHop for 4 years, and I'm the sales director for your region. So I want to give you an introduction into what network the detection and response is, how it fits into the global security infrastructure, and what differentiates ExtraHop from other vendors, and what can it do for you. So a few words about ExtraHop. ExtraHop is a company from Seattle, based in the United States. We started 2007 with an incredible technology. It is still the most effective network traffic analysis technology on the market. It is capable of analyzing IP protocol in an incredible, fast and scalable way. And in the first years of our company, we were using this technology mainly for use cases of network performance monitoring and application performance monitoring. Then after a few years, we added machine learning, artificial intelligence modules to it. And we know one of the top leaders in the world in the market of network detection and response. You can see a couple of our clients here. These are companies that are ExtraHop clients and have been ExtraHop clients for many, many years. And I'm not saying this is a small ExtraHop installment at these companies. These are mostly strategic customers of ours that use our technology for security or for application performance monitoring. Let's talk a little bit about NDR, network detection and response. What is this? Actually, Gartner in 2018 started finding this technology, which was formerly called NTA, Network Traffic Analysis, and they renamed it Network Detection and Response. They then formed something that some of you may have already seen. It is called the SOC Triad. The SOC Triad really is a collection of technologies that, when used jointly, it will give you 100%, or as I say, a 360-degree visibility on your security infrastructure. There are 3 pillars to the SOC Triad. Most companies nowadays have a SIEM system in place. SIEM was one of the first technologies being used because it was the only technology at the time that was able to collect data, index those data, and use these data for searching and analysis. Then in the second wave, companies were deploying mainly EDR, endpoint detection, or EPP, endpoint protection systems. This came out from the former antivirus, next generation antivirus technologies. And there's some very good products nowadays in this market for EDR. And but what Gartner found out that actually, if you have these 2 technologies, there's a big part that you are missing: the network. Most attacks will come in through the networks, will travel on the network, and they will attack through the networks. That's why this is so incredibly important. Yeah, and we found out that you can manipulate log files. There are hackers that want to have control of a system. They can manipulate log files. They can delete log files. They can prevent the systems from sending log files. And the good thing about network detection, you cannot manipulate this data. Network data is as close to the truth that you can have. So this is really the missing piece that many companies are missing today. And I can tell you, in a few years, every mature company will have a network detection system in place. It's something you cannot live without. Yeah. Here's a little example of a script. When you have control of a server, you run this script and the log files are gone. That's why log files are not the ultimate truth anymore. You cannot rely on visibility of log files. It's so easy to manipulate or to delete. And Gartner also said that in the next few years, about 60% of security budgets will shift to the area of detection and response. Protection and prevention, that's where you find the firewalls, next generation firewalls and IDSs, is something that is important, but it will not protect you from being breached. Breaches will occur, and you need some ways, some technologies to detect them as quickly as possible. So you cannot live without detection and response technology. That's why it's so important. Most customers, when it comes to advanced threat detection in a post-compromise world, tell us they have no visibility. Yeah, really, if you think about, do you have visibility, or can you see your transactions and the communications that are running in your data center or in your cloud infrastructure? Probably not. That is because most companies don't have this type of technology. Some of them have some NetFlow-based tools. They don't give you full visibility. They give you a rough idea, but they don't give you any details. And that is also because a lot of traffic, between 60–70%, is encrypted. If you don't decrypt, you will not have full layer 7 visibility on what's happening. So decryption of traffic is essential in our view. And because of these missing technologies, we have these frightening 200 days of dwell time. That's a time it takes a company on average to detect that they have been breached or that an attacker is still inside the system acting. 200 days, imagine that. In the US, this time is a little bit shorter because it has more and more modern technology mainly, but 200 days in Europe. So that number is really scary. And about 70% of our customers tell us that log files have been manipulated or deleted in the latest attacks they have seen. So network detection, where does it live? It lives inside the east-west corridor of the network. It's not on the perimeter. It can be installed in the perimeter, but it has more value inside the east-west traffic. So communication between web service, database service, Active Directory, DNS, storage, etc. That is important. You have to look what's happening here because that's where the attacks occur. So any user accessing any of these servers, what we call the crown jewels in any company, that is what you have to protect. And that's what you can see in the east-west traffic. That's where ExtraHop or NDR in general is working. So many companies said, well, but you know, I have my IDS, I have a SIEM, and I have endpoint, and I have a forensic tool. Can't that do the same thing? And the answer is no, it doesn't do the same thing. It doesn't have the intelligence, it doesn't have the machine learning, it doesn't have the details of analysis that ExtraHop has. An IDS works on patterns. Yeah, it will never detect a zero-day attack. Endpoint is nice, but there are attacks that don't run through the endpoint, run between the infrastructure components, and you will not be able to see that, and so on. So NDR is a different cup of tea, I would say. So we are analyzing the inside, the dark space within a data center or even within the cloud. When I refer to the data center, you can use it also synonymously for cloud workloads. We do the same thing inside a public cloud, ERRS, infrastructure as a service, and we were observing what's happening inside the data center. So as I said again, you cannot put an agent on each of these devices. IoT devices, no agents. VoIP phones, no agents. Bring your own device, no agents. And not all of them produce log files. So the network traffic is the only way really to analyze it. But then 70% of the traffic is encrypted. What do? You get mostly layer 4 NetFlow based visibility. You don't have any insights. So you have to decrypt. And we from ExtraHop, we have a technology that is able to detect and decrypt SSL and TLS 1.3 in a passive way, without man in the middle, without a proxy. So completely passively, we decrypt the traffic and look inside and see what's important. So when we do the analysis and we have detections or any events that we think it relates to a security-based detection, we classify that automatically into these well-known kill chain phases like reconnaissance activities, privilege escalation, command control, lateral movement, etc. And on top of that, we have incorporated a couple of frameworks which are very common in the security world, like the MITRE ATT&CK framework. I would say that about 80% of customers are using the MITRE ATT&CK framework as a reference for their work. In addition of that, there's the NIST framework. There's something like the CIS controls you have to incorporate. And we do that with ExtraHop. So we make reference from our detections to these different frameworks. There are different types of detection. There are some detections based on rules that we have created for you. You can create your own rules. There are threat intelligence feeds inside the system. There are some signatures in the system, but the most important and most difficult part actually is the anomaly detection and the behavioral detection based on machine learning. This is an incredible, complicated thing to do, and we're doing that in the cloud. It's the only way to do it correctly, because we have over 1 million different machine learning models running over it, and that's impossible to do on premise. So if anybody tells you that this can be done on premise, that's a lie. That's not possible. So the detections include things like peer group detection. What's normal behavior for a group of users, or normal behavior for a group of devices? How do they work normally, and which one is really bailing out of that. Who's doing things different? Why does a laptop in the accounting department needs to talk SSH protocol? Or what if an IP camera all of a sudden opens an FTP server or an FTP protocol or SSH or something like that? So these are typical anomalies based on peer group detections. When you install ExtraHop and you give it a data feed, we will automatically identify, discover any device that's communicating on the network. Everybody that speaks IP, we will see, detect, and investigate. So ExtraHop works 100% on traffic analysis. We do not connect to Active Directory, or we don't ping, we don't poll, no log files. We'll purely analyze IP protocol. And this analysis is so deep that we are able, first of all, to detect any device on the network. We will know what hardware, what software, what operating system is on it, what kind of protocols is this device talking as a server or as a client, who's talking to whom, and not only who's talking to whom, because any NetFlow device can tell you that. We'll tell you what are they talking. We will give you layer 2 to layer 7 details about the communication between these devices. And that is essential for advanced threat detection. We will detect reconnaissance activities, lateral movements, automatically inspect any communication with a domain controller or with a web server, file server, CIF server, etc. And you can drill down from any of these detections or devices or communications and go down to packet level detail to see exactly what is happening in this detection or this event or this communication in general. We will detect unusual behavior based on machine learning. There are some things even that may not sound critical, like HTTP 500 server errors or HTTP 404 errors. This is not a security critical event, but it may be part of an attack. So when you detect a large number of 404 errors, it may be an indication that there is a web directory scan happening. And if this web directory scan is associated with some other events, it can form a logical pattern of an attack. And you need these little details to make sense out of an event pattern. So we will detect deviations from normal behavior, and that includes even application behavior like HTTP, database, SQL, DNS behavior, errors, response transmission timeouts, etc. So a lot of things that are maybe not only important for security, but also for the general availability and the performance of the network. That's also part of what we do. So we are fluent in over 70 protocols, higher layer protocols that we analyze. On top of that, you can create your own dashboards based on applications, based on application protocols, a domain DNS dashboard, an Active Directory dashboard, a CIF server dashboard. Within a minute, you create your own dashboards and get yourself a customized view of what you want to see. These are the protocols that we analyze by default. And that means this is not DPI, it's not pattern matching like other vendors in this market do. This means we understand these protocols. We know exactly how they are. We call that protocol fluency. And we will know exactly if this is really a MongoDB behind it. If this port 80 communication is really HTTP, nobody can fake a port or protocol to us because we understand the protocol. We understand the TCP client state, the TCP server state, and we will analyze all communication based on our application fluency that we have. The big difference between ExtraHop and any other solution on the market is that we not only inspect the header of a network packet, and it's not NetFlow. We will inspect the whole packet. This is the only solution that is able to do a full packet analysis up to 100 gig in one single appliance. So that means we analyze a complete packet, we analyze a payload, and that will allow us to see things that other systems just cannot see. An SQL injection, cross-site scripting, a vulnerability, an exploit, etc., which is based in the payload. There's no other way to see it than looking at the payload, and that's what we do. So it is almost like having a Wireshark that's 24/7 analyzing any communication on your network. And combined with the machine learning intelligence behind it, it can't go any deeper. So we have appliances that can analyze from 1 to 100 gig, one appliance, including actually the decryption of the protocol without performance impact. The way it works, we receive a copy of the data feed. We will do the analysis of the network packets in CPU. Normally, we throw the packets away and produce what we call wire data or metadata, and only keep them the metadata. If you like to keep network packets, if you're a forensic guy and you like to have those, there's an option of putting a second appliance in your network and keeping all the packets. That will allow you to do further forensic analysis afterwards under one central UI. So actually there you have the metadata, and a subset of these metadata is being sent to the machine learning process, which will then detect anomalies and suspicious behavior. The sources of data that you can use can be a span port or a mirror port. It can be a more professional TAP or network packet broker environment, or it can be a virtual TAP. You can put virtual taps on VMs, virtual taps inside a public cloud system, like Amazon is using what's called the traffic mirror feature. Google Cloud and Microsoft Azure have a virtual tap that you can use. So it's totally transparent to us. All we need is network data being sent to ExtraHop. We will then decrypt it, make a full layer 2 to layer 7 protocol analysis, discover any device, application, VM, user, etc., and put these data into an internal database, which we call the record store. The record store keeps all the transactions, has a relational database behind it, and is being able to relate all this data to each other and allow us to search for data and compare, etc. This internal record store can be on-premise or it can be in the cloud for even faster searching and more look back. At the same time, very important, no security product lives alone in this world. There's always a set of other tools, and we have a fully bidirectional API incorporated that will allow us to incorporate or integrate with any other security tool. Like we have a full API integration with Splunk, with IBM Curator, with Logarithm, with any SIEM system practically. We can integrate to do automated response with firewalls like Palo Alto, Checkpoint, FortiGate, NAC systems like Cisco ISE or ForScout, source systems like Phantom, Demisto, or ticketing system like ServiceNow, Jira, where you can create automatically a ticket based on detections or based on any threshold of an event. The same thing in the cloud. Yeah, you can go to Amazon Marketplace, just click on ExtraHop, and in 20 minutes you have ExtraHop running in your AWS VPC, or in any other case, you can just install a machine image, an ExtraHop machine image inside your VPC of Microsoft, Google, or any cloud platform to do a full packet analysis of your cloud workloads. The only solution that I know that is really packet analysis based. All tools that are being offered by the cloud providers are flow-based or log-based. Most of them are log-based actually, and they're not free, so they're quite expensive. So Amazon, CloudWatch, CloudTrail, etc. These are expensive tools. So all you need actually is a console, yeah, the ExtraHop command appliance that allows you to monitor your cloud traffic or your on-premise traffic or your hybrid environment actually. So once we analyze the network and we get all this valuable information that is important for your security guys, so like login credentials compromised, is an attack on my system, is there unusual activity, etc. Since from our legacy we come from the application performance monitoring world, we also incorporate all the analysis of the network and the applications. So ExtraHop is actually a combined platform that, besides of being NDR, it's an NPM, APM platform, everything on the one console. More than 6,000 different metadata are being analyzed here, and that's incredibly valuable for not only for the SOC team, but only for the NOC, also for the NOC and for the IT operations team in general. I know that in many companies, the SOC and the NOC are fairly separate, but there's a trend in the industry that SOC and NOC are moving closer together, and we even have some customer that's call it a SNOC and combine actually the efforts between those two, because there's one reality, it's that there's only one network and there's only one set of packets. So once you analyze the network and the network packets, there's so much information in here that is valuable for each different department of the infrastructure. So the network administrators, for example, they're interested in layer 2 to layer 4 metrics. What about TCP, flow stalls, host stalls, Nagel delays, multicast frames, frame sizes, etc. So all of that, for the network administrators, they can create their own dashboards to do that. So server teams, they have a look at the applications based on HTTP, the database admins looking at SQL traffic and all kind of database activities. Do we have any table drops in my network? The security team is looking at the security integration. We have a full Citrix layer 7 analysis. The business analyst is they're looking at the usage of applications maybe, and the application owners, the DevOps people, they look, how is my application performing inside the network? Sometimes a badly behaving application or latencies may not be a matter of the network or the infrastructure. It can be simply be a badly written application. And you can find that out by looking at how the application is performing in the network or in the cloud. So security posture for DevOps, for example, is an important piece of the different use cases for ExtraHop. So that will allow us actually to use ExtraHop as a shared tool in any infrastructure, not only for security, but also for network and IT systems operations in general. And it'll allow companies to retire legacy tools that are little islands. We have an API that can share information with any other system. So what we find usually is 10 to 15 different monitoring tools inside the customer, then many of them are really totally outdated. So when you have network monitoring tools like NetScout or Riverbed, App Response or Viavi or whatever, you can just retire them. If you have ExtraHop, you don't need them anymore. So we will cover a lot of different use cases for application, network, and security monitoring. So what we do, we eliminate blind spots. We give you really 100% 360-degree visibility on all your infrastructure, even inside encrypted traffic. We will detect threats that other tools like seams or endpoints will simply miss, which they cannot see. And this will allow us to allow the customer, so to speak, to respond a lot faster. So why 84%? Well, this is a number that Forrester Research discovered when they actually made a study with ExtraHop customers and asked them, okay, what has changed for you since you have installed ExtraHop? And these customers say, well, that we are responding a lot faster to threats. And we have a return on investment of 165% in the first year. That is something we hear, and that we have that Forrester report here, which is probably in our web page to download. And this quote here is something that's very typical. Network detection is a pretty new technology, but every time I speak with a CISO, they tell me, we have had our SIEM for a long time. We added EDR, but we understand we still have a big, big hole. There's a lot of things we don't see, no? And that's a network. So there's no way for a mature company around employing and installing an NDR. So beside of the complete visibility and the real-time detection, there's an important piece. And when you analyze or when you look at different NDR solutions on the market, look at the investigation part. That's important. How does this tool allow you to investigate the detections? It's not good enough to have a detection. You have to understand, where does it come from? From which user did it come? When exactly? How did the attack start? What other events were part of this attack? So this guided investigation is a very important piece to understand and to improve your security posture. And ExtraHop has this workflow that allows you within a few mouse clicks to go from the detection to the validation, investigation, and to the root cause of any problem. So down to packet level detail, really in a few mouse clicks. For every detection we fire, we give you proof where this detection comes from. We have a reason for this detection, and we will explain you exactly where it comes from. So the typical problems we solve is breach detections, insider threat detection, ransomware defense, integration into the SOC, red team, auditing team. Some companies do complete audits with ExtraHop. And a very important part actually is reducing the attack surface. You can only be attacked if you have weaknesses in your network. And very often these weaknesses are weak cipher suits, expired certificates, unsecure certificates, SMB version 1 servers, etc. ExtraHop give you in a minute, will give you complete visibility on the situation, the status of your certificates, your cipher suits, and will help you to improve that. So the use cases for some companies, we started with a triage and troubleshooting use case based on visibility. And then it went further to application visibility and then cloud migration, data center consolidation. For these use cases, it's very important that you have visibility on the dependencies of the of the applications, which transactions form part of this application. So for consolidation of data centers or going to the cloud, you need to know exactly what dependencies exist for each one of them. So SOC modernization, cloud security. We're unique in cloud security. I don't know of any other system that does anything like us. Hygiene and compliance. So these are all different use cases that you can cover with ExtraHop. So what about response? NDR means network detection and response. ExtraHop does the part of detection. We show you exactly what's wrong. So how do you respond? Okay. ExtraHop is a passive platform. We don't act, but we have an API, and we use a professional system inside the infrastructure through API calls to react to incidents. So that means that our API can trigger responses through an endpoint system like CrowdStrike or Microsoft Defender or Carbon Black or whatever. We can react with an API call to a SOAR tool like Phantom, Demisto, Cortex, to any firewall or to a NAC system. It's a very clever thing to close a port using a NAC, and you can do that just with an API call. So the most professional way to respond is blocking through API and investigating at the same time. There's some vendor on this market who claims they have an automated response by sending a TCP reset in the network. That is not a professional way of doing it because it doesn't remediate the problem. It shuts down the session for a minute, but the session will come up again, and it shuts it down again, and will come back again. So that's a ping-pong game that goes on forever. It will never really take the problem away. And hackers know that. So what they do, they base their attacks on UDP. And then the TCP reset is not possible anymore, or ICMP, etc. So look at API capabilities when you investigate a solution. So automatic remediation with systems like a CrowdStrike or any other or any SIEM. So if you are able to integrate actually these three pillars, you are in good shape. That's a good way to protect your infrastructure. And that's Relax. So that's a theory of our product. I'll give you a few hints about deployment first before we go into a live demo. So let's just jump to a possible data center situation. So this is a data center. We will want to analyze east-west corridor. So an easy way to do that is actually attaching to a span or mirror port of a core switch. That usually gives us the whole or most part of the traffic, but there's a weakness to this. Usually mirror ports are the first ports that are being dropped when the switch has a high CPU load or when there are any problems here. So that what's happening, it drops the packets or it drops a complete port. So that's possible, but it's not the most professional solution. A better way is actually to use taps and a network packet broker to aggregate these different tap ports. Not every company has a possibility to do that. but my recommendation is to use tabs or even virtual tabs on a VM host is a possibility to do. So, but both things are possible. The packet broker has a couple of advantages. It aggregates ports even from virtual cloud workloads and can send it, aggregate it, filter it, and do load balancing, and then it attaches to a tool farm like IDSs or Splunk or SIEM or an NDR system. So deployment, how can that look like, a deployment with ExtraHop? So the most typical case is we have a company with 2 data centers. So what you need is a sensor inside a data center. Why? Because the big part of the traffic, the big pipe, is between the mirror port and the sensor. And you don't want to send this traffic outside over a public line. So that's why the sensor has to be inside the data center. If you want to have packets inside the ExtraHop appliance, you need a second appliance. If you want to correlate packets with records and metadata and so on. So you need this optional second appliance. Most companies don't do it, only the ones that really like having forensic data or need forensic data for compliance reasons. So you have a central console, which is called control plane. This control plane is able to monitor hybrid environments to your data centers, your virtual sensors inside your private or public cloud. And you have something which we call the record store. That's where the layer 7 transaction and the records are being stored in an internal database. So the control plane and the record store can be on-premise, but if you want to make life easy, put it in the cloud. So we have the option to have all of that in the cloud. That means deployment of ExtraHop is so easy. It takes less than an hour. Just put the sensor in your data center, give it an IP address, attach the data feed, and then a little bit of configuration here. It attaches to the cloud services, and then you have everything up and running. Can't be any easier. So that's the way that ExtraHop usually is being set up. So this was theory. I will close this presentation and we'll move to a live demo on our website. So I will show you how to get inside that, because this is a demo that is open to anyone. Just go to extrahop.com, and on the upper right corner you will find something that says Start Demo. And this is not a simulation. This is a real ExtraHop system based on Amazon AWS. You just click Start Demo, and then the AWS system is up and running. It goes incredibly fast. So there are a couple of guided tours here which you can choose. Be the hunter, stop a breach. But in my case, I go to the manual mode, click here, and we'll enter a demo. And now we are in the system, and it will offer you sometimes 2 more options, not today. And this is the ExtraHop console. This is an ExtraHop system, totally virgin, no configuration done, no customizing. This is as it comes out of the box. So the first thing you do in the upper left corner, you choose the time interval. Which time you want to see? Last 30 minutes, last 6 hours, last 7 days. Or I want to see what happened, I don't know, last Friday at 1400 or last week. So you choose a custom time frame. For the purpose of our demo, I go to the last 6 hours, which is a good sampling interval. And we look at the traffic that occurred in the last 6 hours. So we will have here an overview of detections by category. So we have 9 reconnaissance activities, we have 6 exploits, we have 6 lateral movements, command and control, etc. In the middle, we have the top offenders, workstation, physicians, web server, an accounting laptop, etc. So we have a lot of different devices with detections. And here on the right-hand side, we have the detections by type, the detections by risk score. So the risk score is important. It goes from 1 to 99 in theory, and the higher the number, the more important, the more dangerous this threat is. Before we go into detections, we will show you the basics of the system. It all starts with assets. Assets is what we discover when we get the data feed and we start analyzing everything that comes in. So we will receive data and we will see, we have a total of 280 devices here. It's a small environment. And we find all these different protocol activities. So we find 6 database servers, 11 database clients divided by protocol behavior. We have 17 CIF servers, we have 24 DNS servers, and so on. So, for example, you want to see your CIF servers. You just click on this CIF servers, you see all of them in one overview. These are the 17. This is all the protocols that these 17 servers are speaking. Yeah, server activities, client activities. So if you want to choose one, you just click this accounting file server. You can go directly to the detections of the records of the packets, but let's go device overview and we'll have a look at this device. So this is an accounting file server. It's a Dell server. Yeah. We found 2 detections on it. This are the protocols that is being spoken. It's mainly a CIFS. We have other protocols, but very little. Yeah. These are the client activities. Every device has client talks and server talks. So we can look at detections. So actually this device has 2 detections. One is a ransomware activity. The other one is a data staging activity. They're connected to each other. Yeah. You can have a direct look in real time, all the communication between this file server. Who is he talking to in the last 6 hours? So as you can see, he's talking to main controller, nothing critical, but he's talking to a web server, and this one is red. That means there is a detection here. With the right mouse click, you can go directly into the layer 7 communications between these 2 devices. And this is what they are talking in the last 6 hours. Every communication between these 2 devices are being seen here. It's mostly web traffic, HTTP 80. You can add more fields if you want to have more details about this communication, etc. And you just can add these fields. But that's just to give you an idea. If you want to go back to detections, let's take a look at how to investigate a detection. So on the left side, we have a couple of detections that we found. Actually, if you're interested in different detection techniques and you like the MITRE ATT&CK framework, just click here and you have a full listing of the MITRE ATT&CK framework, and everything that's blue is actually a detection we found on the network in relation to the MITRE ATT&CK. So we have an exploitation of remote services. We have 3. Okay, here they are. We have 2 remote service launch. One of these activities. You want to see the MITRE documentation. Here it is. So you can investigate and understand better what kind of detections do we have here. But let's go back to the detections. Let's take one and make an example for investigation. There's something I like very much. I see here an exploit. Exploit is kind of neat because an exploit is something that cannot be detected through NetFlow or through a header detection. So you have to really look inside the payload. And when we click this, you will find some information about this exploit. And it's very important to have that explanation actually, because you want to go into details. You want to understand it. So we tell you that the web Drupal server has received an HTTP post that is like it's actually a remote code execution vulnerability based on Drupal 7 and Drupal 8 applications. You have some more explanation here of the MITRE technology in general. How do we count the risk factors? How complex is it? How deep is the business impact of this one? It explains you the vulnerability, explains you the attack background, in all details. It explains you exactly how it's being performed, this attack, what you can do to mitigate it. And here you find more references of the OWASP framework, for example, about exactly this vulnerability. You find the CVEs and the MITRE, etc. So a lot of additional information, which can help a level 1 SOC employee, to get formed, to get educated, to learn more about this type of different events. So what do we have? We have an offender. You see that camera icon. That means our threat intelligence feed has identified this IP as a malicious endpoint. It's actually in Russia, poor guy. So it is an endpoint in St. Petersburg. It comes up on our threat intelligence feed as a known bad actor, and it's communicating with our web server. Our web server, the Drupal, is a Windows server with Apache application. We have the usernames actually on this one. We can go directly to activity maps, records, or to device overview. But at this moment, we want to look and investigate the detection. So what else do we know about this type of detection? We have the full payload of this exploit. That's interesting because it's very difficult to get, actually. Yeah. So when we look at this payload, if we want to know more about it, we click here and we have the packets. These are 17 packets. This is the exploit attack. You can download the PCAP and investigate further if you want to. Yeah. Let's change the time frame a little bit. So we see the connection between the web directory and right after that the exploit. Let's take a look at, for example, as a suspicious CIFS file share access. So we have this device is an offender. It attacks a victim. We have a ticket already open. This is a Jira ticket, which is incorporated through API. We have a ticket number, who is working on the ticket, what's the status of the ticket. And so we have a couple of different CIFS file share access detections here. And we're going to investigate this one. So we have a suspicious file share access. That's the victim. And we can see all the files actually that have been investigated here with all the details. So we know exactly which files have been read, more information about the MITRE techniques, etc. And yeah, about the attack background, mitigation options, and some MITRE frameworks about it. Good. I must realize there is a technical problem with this demo because there's a couple of things missing that usually are in here. So let me load it up again. That has never happened, but I am missing a couple of detections here. This should be part of this, which is it's a bad moment for this. Let's go back to the detections. Yeah, there's a lot of different things missing here. So I have to improvise, and I have to go through some other kind of detections. We have a CIFS brute force attack. So what we can see here is this is Drupal server after it's been converted to being an offender. This is the part that I wanted to show, but it's missing actually in the demo. We find that, for example, there was 149 logon failures from this one. Our machine learning would suggest no, 0. Normally we don't expect, or maybe 1 or 2 logon failures, but not 149. This is clearly an error which can be detected through baselining. And it's trying to attack these 2 workstations here, physician 4, physician 3. Let's investigate this one. So we see that oh, now we have the complete picture. After this Drupal exploit, actually the web server, the Drupal server, yeah, became actually an offender, and then it actually affected the physician workstation 4. It was attacking these 2 workstations, and we can see these are the usernames that he was using. So he was attacking. He was trying to get SMB access with all these different usernames. You can see them all here. Yeah. And so you can see he got some response packets, but there is no real login until actually with this username. So he was trying this username, and actually finally you see the good bytes in. So he got access to it, and so he accessed the server. So the workstation, after it was actually attacked, it becomes an offender. It starts some other activities. It starts a PowerShell remote activity, for example, using this different username again. You can drill into the metric details, but let's go further to network privilege escalation. And here to the CIFS data staging, this is interesting because we see actually that it's attacking a file server, and it's reading, using this username, all these different files. So all these files here, these nice spreadsheets from the accounting department are being read. And 54 minutes after that, what's happening? A ransomware activity. So before there's a ransomware activity, you need to have access to the CIFS server. So let's look at the details. Okay, here we find the encrypted files. The files that before have been read, these are the files that were investigated. At this point of time, they are encrypted. That's too late. We should have reacted 50 minutes before that through an automated call on the endpoint or on the NAC, closing out that user. But here it's too late. Files are encrypted, etc. There's more stuff going on. Actually, there's a crypto mining protocol that's being implemented here. It's something we don't expect to see, but yes, we have a lot of different bytes with a stratum, typical crypto mining protocol, etc., etc. A tech background about crypto mining. How critical is it? Yeah, could be critical because it takes up your resources. It's also an indication that you may have been hacked. So there's another possibility of what you can do. You can acknowledge actually a detection. If you feel that this detection is a false positive and you don't want it to come up anymore, especially in the first 1 or 2 weeks during the baselining learning period, you may have some false positives. You can acknowledge this one. You can say, okay, I don't want this to come up as an error anymore. We know that. So the acknowledgement actually suppresses this detection to come up again. Okay, that's an example of the depths of investigation that you can get to. With really a few clicks, you get from the detection to more details, etc., and to the packet level details. So you see all these different kinds of activities. Most of them are being triggered by the machine learning, a DNS brute force here. Let's have a look at that. Investigate host queries. So we have the different host queries. If you're more interested in seeing, okay, what was this query to this host here? Click on here and you get exactly the 2 DNS requests that are being triggered to the domain controller. You're interested in investigate this one, you click here and you have the packets. It's only 2 packets because it's just a DNS request. But it's nice to have the possibility to investigate that and to go into details. Here more about the attack background. It's a system which allows you to learn and become more mature in your SOC team. So that's an example of how you investigate detections. I want to show you a couple of other things, dashboards that come with a system but are not necessarily part of the security detection part. There is a general activity dashboard. As I said, we cover more than 6,000 different metadata, and so we have any protocol on the network: CIFS, SSL, HTTP, 8080, MySQL traffic, NFS, RTP traffic, etc. Network round trip time, etc. You can drill down by client, by server, go into the layer 7 records. What about the network round trip time by server? That could be interesting. maybe not for the stock, but maybe for your application or your infrastructure team. Yeah. And look at the round trip mean time. 350,000 milliseconds. It's definitely too much. You want to investigate. Click here. You have the different flows. Yeah. If you have the trace appliance, you have the packets here. And if you want to have more details, there may be more information for you that's interesting. You're going to add some fields here. What about access time? What about, I don't know. Well, certificates don't make a lot of sense in this context here. Yeah, but there are a lot of different fields, as you can see, client 0 on Windows, etc. Yeah, these are all part of the metadata that you can include and take out from this communication, egress interface, etc., etc. You see the wealth of information that's yeah, potential SQL injection. So there are a lot of different fields you can add, whether it makes sense or not. So this is mainly performance based. So let's go back to the activity dashboard. So the activity dashboard gives you a general overview of your network protocols, of your application performance, HTTP errors, DNS database errors, database errors. Which kind of errors do I have in my database? I want to know that because my business may depend on it. Yeah, EcoMap table doesn't exist. Too many connections. That's critical. If you get 35,000 times too many connections, that means an application is dropping a connection to the database because there are too many connections. So why is this happening? Yeah. So here you have the exact details, from whom to whom, when exactly did that happen. And you want to see the packets, you click here and you have the network packets exactly for this transaction. Okay, this is the application or the activity dashboard. I call it the application dashboard. So I haven't completely finished. So it covers HTTP, DNS, SSL, Citrix load times, launches, Citrix aborts, yeah, load time, network latency, etc. So why do I have 7 seconds of load time? What about DNS errors? What about LDAP errors, LDAP responses? Yeah, plain text messages in LDAP, etc., etc. So zip traffic, we have a complete zip VoIP analysis solution in here where you can analyze the MOS values of phone calls, the DSCP packets being used in telephone calls, so you can check at the median MOS values, etc. The codecs that are being used. You can click here and get into every phone call that you want to analyze. If you want to do that, well, that's a couple of million records. Let's have a look how to. Okay, it doesn't come up. That's a typical presentation effect. But anyways, data is here, so you can look at the zip calls and see at the performance of your real-time communication in general, and look at the performance in general for all your applications, RTCP, Kerberos, and any protocol actually you can imagine. Then there's something called network dashboards. Actually, these are the 4 dashboards that are included. You're not limited. You can install hundreds of dashboards if you want to. So this is mainly for the network guys, layer 2 and layer 4, unicast packets, how much broadcast, multicast packets do I have, frame types, frame sizes, transmission timeout, 0 windows, nagel delays, receive throttles, yeah, round trip times, as I said before, packet count, DSCP packets, multicast groups, etc. So you can drill from each one down to the multicast groups, to the complete packet capture of this. So drill into DSCP packet types, view more DSCP packets, etc., etc. So who's communicating with a CS1 DSCP packet? Yeah, click it here. You have it, and then you have all the different record types that you can choose and filter down. So, I mean, there's so much you can do. There's no limit. Another dashboard, which I feel is one of the most important ones actually, is the security dashboard. That's something I mentioned earlier. It would give you a short overview, about the threat intelligence feeds, what was launching, what came up as threat intelligence, suspicious connections. What about SSL sessions, weak cipher suits? What kind of weak cipher suits am I using? What kind of expired certificate sessions do I have? Which ones are the expired certificates? Yeah. What about self-signed certificates, wildcard certificates, expired certificates? Yeah. So who is using this certificate? Let's go to the server activities using this certificate. Who are the top group members? Who is using it? Yeah. What kind of SSL or TLS versions are being used? Including handshake time. You see the wealth of information that's in here. You just have to customize it the way you want it. We have professional services that can do that for you, or you can do it yourself. It's really easy. Adjusting your dashboard, right mouse click, create chart. Okay, and you have that dashboard. You don't like this way, you can have it this way, or you can see it like that. Okay, you want to add some metrics? Add a metric. What am I interested? HTTP server responses. Boom, here it is. Here they are. Maybe that's a better way to present it. So you can correlate any of these 6,000 metrics to each other. How does network performance and application performance and DNS performance, how do they relate to each other? Where can be the problem? If you have a slow performance on application, what can be the reason? Just adding the different metrics here from your database response time, it can give you an indication, and you can easily find out in troubleshooting what problems do I have in my network. Add to dashboards, create dashboards, and then you create a new dashboard with your name, and then you can distribute that dashboard to your users based on LDAP credentials, just for the, I don't know, for the network team, for the database team, or for whoever you want to give it to. So that's ExtraHop. That's the wealth and the power of ExtraHop for any kind of visibility you want to have into your IT infrastructure. If it's on the network, we will see it. Yeah, and you can drill down from a global view of your overall communication. So this is SL clients. I want to see all service. Yeah, save. And you have a real-time view of exactly what's happening, who's communicating with whom, and what are they talking to each other. So, and this level of detail will allow us actually to detect anomalies and help you with investigation. So I would say at this point of time, I want to close my presentation and the demo. I can encourage everybody to go to our website if you want to see it in more details. It's available for everyone. The first time you have to put your name and your email address on it. The second time it's not needed anymore. And so let's go to questions and answers.
Dear Christian, this was very, very interesting presentation. I have to admit, what I learned is basically that logs are not anymore so reliable as they were before. The second thing that I saw from this presentation is basically that this tool is not only helpful to security guys, but it can be helpful for troubleshooting for network guys that are solving some problems regarding delays, etc., etc. So I believe that this presentation was really informing. We learned, I hope, all of us a lot from your presentation. And now I would leave the floor to our attendees so they can ask questions, and hopefully we can give them, we can provide them with answers. Dragi moji gosti, učesnici, evo, otvoren smo za pitanja koje imamo za Kristijana. Dok ne dobijemo neko pitanje, evo možda da postavim ja neko svoje pitanje, odnosno da upitam. Dear Christian, I would like to ask example given how fast can this tool catch the network flow that is not at usual level, and what are preconditions? Let's say, is there some kind of baseline analysis so the tool can learn what are usual traffics and to be able to identify anomalies within the network?
Mm-hmm. Okay, as I said in the beginning, the collection of metrics, the identification of communication, everything is near real time. Yeah, maybe it takes a second or so and you have it. The granularity is millisecond for all of our metrics, and most of the network detections are also real time, except the ones that are based on machine learning. So they can take between 1 minute and about 6 minutes, depending on how complex the calculations are. So let's say of those 100% of different detections we have, let's say 40% is onboard detection, 60% is detections based on machine learning. So depending on the complexity, you can have a response from a machine learning within a minute, or it can take 5 minutes, really depending on how much calculation is being done.
And what is the most effective ways of, let's say, utilization of this tool? We saw at the beginning that you propose a triad of tools: SIEM, EDR or XDR plus NDR. Is this, let's say, enough to catch, I can say, 80% of threats, or do we need something else in addition to be really effective?
Yeah. Yeah, I would say that's enough. I mean, you've seen the power of detection. Normally, when most companies we speak to, they usually have a SIEM. If it's a more mature company, especially in the banking environment, they all have a SIEM. So the question is not what's better, a SIEM or an NDR. The question is, shall we add NDR to our infrastructure? Shall it be an add-on to our SIEM? So that we keep the SIEM for compliance. Most companies, especially in the payment transaction and the banking industry, they need a SIEM for PCI, DSS compliance, etc. So I have customers from other vertical markets where they ask me if I have to take a decision whether it's going to be a SIEM or an NDR, and I have to choose between one of those two. I would say that an NDR gives you a lot more visibility and especially a much faster workflow than a SIEM. A SIEM is a lot more complex. It requires a lot more manpower. You need more people to work on a SIEM. They have to correlate a lot of manual things. So ExtraHop is fully automatic. Everything you've seen here was without any user interaction. Every detection that you saw is fully automatic. So when you have the choice and you have to assign your budgets between one or the other, I personally would go for network detection. But I think that for most people here on this call, this is not a question. It's just a question whether they want to add NDR to it.
I think that we might not understand each other very well. I was asking what additional tools at the top of NDR are required to be really most effective. And in this let's say setting, I was asking about the triad. Are these three sufficient, or we need something at the top of these three?
No, I would say these three are completely sufficient, definitely. What could be important, not every EDR, for example, has a good API. So some of these tools cannot be integrated. So if you have an old-fashioned EDR or an old-fashioned antivirus, I don't want to mention any names, but maybe it cannot be integrated through API. So you don't have this automation possibility. If you go for a very modern EDR, okay, it's easy. We have a plugin for CrowdStrike, for example. This is just one example, or for Microsoft Defender and so on. So there may be others. So that's very easy to integrate. And if you're very old-fashioned EDR, I don't think you need additional tools on top of that, but you may have to modernize your tools with API capabilities.
And one more question about, let's say, isolation of network segments. If any of network segments is compromised, how does isolation of these network segments or PCs or whatever is working with this solution?
Well, ExtraHop is passive, so you have to define, what you have to do. We can advise any system to you. We can send a firewall, for example, an API call and say, launch an ACL, an access control list, for example, or shut down a range of IPs or so on. So it is really a matter of the process. How would you define what do you do when this happens? Yeah, the response part is, it's a manual, it's a thinking process. It's not so much doing, but it's thinking about possibilities, what happens if.
Good. Nedime, ti imaš neko pitanje, evo, hoćeš li uživo ili...
Yeah, yes, I have a question regarding integration of the system with existing ticketing systems.
Mm-hmm.
And what information can be passed through the ticket? And for example, if we have detected attack, I was looking at this demo that you gave us. You give even some mitigation options. Do you provide this information through your ticketing system, through the ticketing systems?
Yeah, I understand what you mean. Yeah. Well, we can send what we call the detection card. The detection card is, let me just go back to the demo and take a look at that. So everything that's on the detection card will be sent to the ticketing system. That usually does not include the explanation like the MITRE technique and detect background, etc. But I must say, I don't know.
Yeah, okay, because okay, I haven't had enough time to analyze everything what I have seen. But one thing is pretty interesting that you give us mitigation options. Those, if we could pass those mitigation options to the operator or agent in charge for the fix, it could be very helpful. And that is why I was asking this. Nothing more.
And now that you tell me, something comes back in my mind. Of course, I attended a lot of presentations from my colleagues, system engineers. These are the guys that really know. Yeah, I'm just copying them. So there is the possibility to actually create widgets. Widgets are dashboards that include the detection card and that include documentation, communication, also this part of the mitigation attack background. Yes, this can be integrated in certain widgets on the ExtraHop. If it can be exported to a ticketing system, honestly, I don't know. But I know you can completely customize the user interface in a widget type of style. And that also includes all this documentation on the attack backgrounds. You can add pictures, you can add text messages and so on. So if you want to, let me know your name and your contact address, and I will ask in my company if and how this can be done.
Ja također preporučujem da kogod ima otvorenih pitanja da naravno pošalje ili na adresu udruženja ili na adresu kolege Matica Knupleža ili evo direktno na adresu Kristijana Burova koji nam mogu dati odgovore na pitanja koja sad ne mogu odgovoriti. A da li imamo još eventualno nekih pitanja?
How much?
Evo imamo Adnana. Adnane.
Hi everyone, thanks for a great presentation. Thanks a lot, Chris. You can hear me clearly?
Yes, yes, excellent.
Yeah.
All right, perfect. Yeah, just before when I clicked raise my hand, I heard somebody saying how much. And then, I'm not sure if you can share it with the audience, but yeah, I would like to know. Actually, I have two questions before I have a how much question. First is about the appliance. So you, as I understood, all your clients actually need to install the physical device in their data center or somewhere in their office, in their network, correct?
No, not necessary. We have virtual appliances, but
there's the cloud as well. So
yeah, no, in the cloud, but also on premise for VM or Hyper-V. So, but there's the limit in throughput. Our virtual appliance, it's just an OVA image that you get, can only analyze up to 10 gig.
Okay.
But in most cases, it's good enough. Yeah. If you need more than 10 gigs, then you have to go hardware.
Yeah, and in this scenario where you have multiple data centers, you have to install the either physical appliance or the virtual one in each of them.
Yes, yes, because you need to be close to the traffic, to where the traffic occurs. So you want to have a sensor there. But everything can be virtual if you want to. Yeah.
But then you mentioned that there is a connection with the cloud, and that's basically for the AI part, right?
Exactly. Yeah, that's true.
Okay.
Yep.
All right.
The AI part is completely SOC 2 and SOC 3 certified. So there is no private personal identifiable information being sent into the cloud on the machine learning part. No IP addresses, no usernames, nothing that can be used. Even if it was intercepted, it's completely useless for anybody else. It's only hashes.
Okay, thanks a lot for explaining. And one question about decrypting all that traffic, because yeah, you emphasized it in the presentation that well, 70% of the traffic was encrypted, and then you have a way to decrypt it. Does that mean that we have to sort of import the master certificates or passwords into the appliance and then use that for decrypting the traffic? Or
exactly, there's like a master or wildcard certificate that you just install in the ExtraHop appliance, and at this moment, every traffic we receive, we will automatically decrypt. Yeah, it will be completely transparent.
Okay, and yeah, I'm not sure if you can share that information here, but I guess it depends on the scenario and the additional add-ons that might be used. But can you give us at least the indication of the price of such solution for, let's say, a small business with one data center and I don't know, 50 workstations?
And licensing policy. What is licensing policy, of course?
Okay, licensing scheme. Yeah, that's a very good point. Let me share one more picture for you that makes it clear. So let's take a look at this picture. There are actually two parameters in ExtraHop which define the price of a system. The first parameter is on the upper right corner, what kind of appliance or sensor do I need? Maximum throughput. Do I need an appliance for 1 gig, 5 gig, 10 gig, 20, etc.? So what's the maximum throughput that I will need? In the beginning, maybe you don't even know. If you do POC, you will know exactly, but I can give you some ideas. For example, a small environment with maybe 100 servers or 200 servers, you will hardly go past 1 gig. Yeah. A 10 gig appliance usually has an environment of 800 to 1000 servers. I mean, any case can be different, but this just from my experience. Yeah. So there are 1, 5 or 10 gig appliances. A 10 gig appliances, let's say, but it's for a company that has 1000 to 1500 servers, 5 gig appliance for 500, 800 servers, and a 1 gig appliance in an environment with 200, 300 servers. So service, what is service? Service is what we see down here. These are the web servers, database servers, Active Directory, and so on. These are the crown jewels. And that's how our licensing works. We don't care how many users. No, we don't charge by traffic, not like Splunk. So all we need to know, maximum throughput and the amount of critical assets or servers. So let's say you tell me, okay, it's a small environment. I have 80 servers, 1 gig. Then I tell you, okay, that'll cost you 30,000 a year. It's a 5 gig system With 800 servers, it'll cost you 70,000 a year. 10 gig system, 90,000 a year. So roughly, okay? Very rough numbers.
Okay, thanks a lot.
Dobro, ili imamo vremena za 2 pitanja možda, ako imamo, evo da iskoristimo vrijeme da postavimo Kristijanu. Ako nemamo više pitanja, ja bi se svakako zahvalio Kristijanu. Christian, thank you for this really wonderful presentation. Zahvalio bi se kolegi Maticu koji je inicirao u našu izvanrednu saradnju i evo zajednički držimo već drugi webinar. Zahvalio bi se svima vama koji ste tu došli da pristvujete i izdvojili današnje vrijeme da pristvujete sastanku. Evo da vidimo. Aha. Ok, mislio sam da je neko postavio pitanje, međutim samo je neko poslao pozdrav. Znači, zahvalio bi se svima što ste izdvojili svoje vrijeme i došli danas da pristvujete ovom izvanrednom događaju, a mislim da je prezentacija sama po sebi bila zaista edukativna, bila je i dosta izbalansirana, možda čak za neku kategoriju korisnika možda malo previše tehnička, ali svakako ja mislim da je bila izbalansirana, smo imali priliku vidjeti i dosta tehničkih detalja za one koji žele da sistem radi, a naravno i dosta ovih stvari sa druge strane da vidimo razloge zbog kojih ovaj sistem funkcioniše. Zahvaljujem vam se svima još jednom i drago mi je evo da kažem da smo na današnjem webinaru imali do sada najveći broj prijavljenih. Ne znamo još dok ne sravnimo brojke da vidimo da li smo imali najveći broj učesnika, ali svakako je veliko zadovoljstvo vidjeti koliki je broj učesnika zadržao se do samog kraja. Matic, hvala.
Hvala tebi, Senate. Hvala svima.
I vidimo se vrlo brzo, možda čak evo, vjerujem da se neki već prijavili i na naš meetup u financijskoj industriji koji će biti održan 3.2.2021. godine. Svi ste dobrodošli i raduje me svako zajedničko druženje. Hvala vam.
Budite dobro, ostanite zdravi. Ćao, čao.
Ćao.